We are from Sacred Heart Canossian College. With the rise of global warming, we aim to use our knowledge to improve air pollution.
Currently, factories, vehicles, or even animal husbandry produce CO2. But there are not enough trees that leads to the increase of greenhouse gases. Then why not remove CO2 from the air to produce H2?
We have made two setups to turn CO2 to H2 and drive electric fans. In the setup, we have used super iron conductor and organic electrolyte.
Polyvinyl alcohol is a crystalline structure similar to salt in small size. By dissolving PVA in water by stirring, we obtain a viscous liquid.
Filtration is then carried out to remove undissolved ones, a solution where part of PVA has dissolved. Polyvinyl pyridone is a colorless polymer binder.
Through experimentation, we determined that a 2-to-1 ratio of PVA to PVP yields optimal results for forming the membrane.
By measuring and mixing the solutions in a cylinder, we pour the mixture into an evaporating dish and allow it to dry for 18 hours. As the solution dries, the thin layer can then be carefully removed and wrapped around two sides of the U-tube, enabling ion movement across the membrane for redox reactions with the sodium metal.
We use propylene carbonate as the organic electrolyte. With urea and heat under reflux, it can improve hydrogen gas production. In the setup, CO2 dissolved in water to give carbonic acid, which improves the production of hydrogen ions.
The hydrogen ions then dissolve in 1,2-propanediol and migrate from the anode to the cathode. The anode, sodium metal, releases sodium ions and electrons.
The electrons flow through the external circuit, traveling through the sodium conducting membrane to meet the hydrogen ions, resulting in the formation of hydrogen gas collected in the hydrogen storage bottle.
To maintain the charge balance, the hydrogen carbonate ions react with sodium ions to form sodium hydrogen carbonate. This process can convert CO2 without adding external heat or electricity supply. Although we lack a superionic conductor to replace Nesicon, we aim to build up a foundation for further development for others.
This following setup is also a core part of our project. When hydrogen gas is pumped into our setup, the fan will whip on, indicating that electric current is flowing along the circuit in the setup. This setup contains a fan, electrodes, hydrogen storage bottle, emitter, and a PEM membrane. The PEM membrane consists of 5 layers: polymer electrolyte membrane, nephron which contains sulfonic acid groups, one anode and cathode. When hydrogen gas is transferred through the duct to the cathode, the sulfonic acid groups dissociate into protons and electrons and also allows the conduction of hydrogen protons to pass through and arrive at the anode. At the end of the air, and they are gathered at the anode. The polymer structure prevents electrons from passing through, but by traveling through an external circuit, electrical energy is generated by the transfer of electrons. The fan can be whipped on.
Thank you.